A volume of 40 milliliters of 0.10 molar NH3 is titrated with 0.2 molar HCl. The value of the base dissociation constant, Kb, for NH3 in water is 1.8 times 10 to the negative fifth at 25 degrees Celsius. Write the net ionic equation for the reaction of NH3 with HCl. NH3 plus HCl gives NH4 plus Cl, so the net ionic equation involves the creation of NH4. So you leave out the spectator ions, which in this case is just Cl minus. So NH3 plus H plus is NH4. The mistake I made was writing the full reaction for the equation, not the net ionic equation. Also, the full equation was incorrect. It should be NH3 plus HCl is NH4 plus Cl minus. Using the access provided below, sketch the titration curve that results when 0.2 molar HCl is added dropwise to the 40 milliliter volume of the 0.1 molar NH3. The titration curve will look something like this, with a initial pH above 7 and a final pH below 7 because it's a reaction between a weak base and a strong acid. So the mistakes I made on the quiz is I had the initial pH below 7 and then initial pH at 7. I misread the problem. I thought it was adding the NH3 to the HCl solution. I thought it was a base being titrated to a acidic solution. So that's why I wrote the initial pH as an acidic pH and the final pH above a pH for an acid. Calculate the pH at the halfway point and label this point on your graph. At the halfway point, the pH equals pKa, and we are given that the Kb for NH3 in water is 1.8 times 10 to the negative fifth. Kb equals 1.8 times 10 to the negative fifth. So Ka equals 1 times 10 to the negative 14th divided by the Kb value. So Ka equals 5.5 times 10 to the negative fifth. So pKa is the negative log of Ka. So the negative log of 5.5 times 10 to the negative fifth equals 9.26, which is the pH at the halfway point. So on our graph, the halfway point is at 9.26, approximately. The mistake I made on my quiz is I tried to use the Hassel-Henderbloch equation, but I miscalculated the value and I got a halfway point of about 4.26, which is not correct, and I also got the wrong volume at the halfway point. Calculate the pH at the equivalence point and label this point on your graph. So since we know the halfway point is at 10 milliliters, the equivalence point will be at 20 milliliters because the halfway point is half of the equivalence point. So also you can figure out when the equivalence point is because moles of the acid equal moles of base. So when there are 20 milliliters of 0.2 molar NH3, you will have the same amount of moles, 4 millimoles, as 40 milliliters of 0.1 molar H+. So you use a BCA table and you result in 4 millimoles of NH4. And since there are 60 milliliters total of solution, the 20 milliliters of NH3 and the 40 milliliters of H+, the concentration of NH4 is 0.6 molar. So then you plug in that value into an icebox and it's a dissociation of NH4. So 0.6 molar NH4 dissociates into NH3 and H+. So the Ka expression is equal to x squared plus 0.6 minus x. But we can plug in Ka for the value we calculated in part C 5.5 times 10 to the negative fifth. So x equals 6.08 times 10 to the negative sixth, and x is equal to the concentration of H+. So the pH is equal to the negative log of the concentration of H+, 6.08 times 10 to the negative sixth. So the pH of the equivalence point is 5.22. So on the graph, the equivalence point at 20 milliliters is about 5.22. The mistake I made on the quiz is I calculated the wrong K value, and then from the table below, select the most appropriate indicator for the titration. Justify your choice. So methyl red is the most appropriate indicator because its pKa is closest to the pH of the titration at the equivalence point, which is 5.22. I was half right because I chose the correct indicator, but I didn't get the full credit because I calculated the wrong pH at the equivalence point. The pH was not 4.26, it was 5.22. If equal volumes of 0.1 molar NH3 and 0.1 molar NH4Cl are mixed, is the resulting solution acidic, neutral, or basic? And explain your answer. So on the quiz I said it was acidic, but I didn't actually explain why. And the solution will be acidic because NH3 is a weak base, so its conjugate acid will be strong, resulting in an acidic solution.